Good day, class. Let's begin our discussion of Chapter 8 on memory. Here's some photographs that we'll be utilizing throughout this particular presentation. Just look at them real briefly here. Now, let's go ahead and talk about what are going to be some of the topics by way of a chapter overview. We'll be looking at models of how memory works, encoding, effortful and automatic processing, sensory, short-term, and working memory, long-term storage helped by potentiation, the hippocampus, and the amygdala, encoding failure, storage decay, and retrieval failure, memory construction, misinformation, and source amnesia, and some tips and lessons for improving memory. So, in studying memory, we need to start off by looking at what memory is. It is the persistence of learning over time through the storage and retrieval of information and skills. There are three behaviors that show that memory is functioning. Recall is analogous to the fill in the blanks. You retrieve information previously learned and unconsciously stored. Recognition is a form of multiple choice. You identify which stimuli match your stored information. Relearning is a measure of how much less work it takes for you to learn information you had studied before, even if you don't recall having seen the information before. Here's a simplified description of how memory works. Encoding. The information gets into your brains in a way that allows it to be stored. Storage. The information is held in a way that allows it to later be retrieved. Retrieval. Reactivating and recalling the information, producing it in a form similar to what was encoded. And also this notion of connectionism, information processing model. It focuses on multi-track parallel processing, the processing of many aspects of a problem simultaneously. It views memory as a product of interconnected neural networks. Now let's look at the Atkins-Shiffrin model done in 1968. Stimuli are recorded by our senses and held briefly in what is referred to as sensory memory. Some of this information is processed into short-term memory and encoded through rehearsal. Information then moves into long-term memory where it can be retrieved later. So, modifying the model. More goes on in short-term memory besides rehearsal. This is now referred to as working memory. Some information seems to go straight from sensory experience into long-term memory. This is automatic processing. So, zooming in on the model. From stimuli to short-term memory. Some of the stimuli we encounter are picked up by our senses and processed by sensory organs. This generates information which enters sensory memory. Before this information vanishes from sensory memory, we select details to pay attention to and send this information into working memory for rehearsal and other processing. Working memory functions. Short-term memory is working in many ways. It holds information not just to rehearse it for storage, but to process it. For example, hearing a word problem in math, keeping it in your mind and solving the problem in your head. We have auditory rehearsal, repeating a password to memorize it. Executive functions, choosing what to attend to or respond to. Visuospatial sketchpad, rearranging a room for furniture in your mind. The executive function is a way in which we integrate some new sensory information with long-term memory. Dual track processing, explicit and implicit memories. So far, we have been talking about explicit declarative memories, facts and experiences that we can consciously know and recall. Our minds acquire this information through effortful processing, studying, rehearsing, thinking about, and then storing information in long-term memory. Some memories are formed without going through all that Atkins-Shiffrin stages. These are implicit memories, the ones we are not fully aware of and thus don't declare or talk about. These memories are typically formed through automatic processing, without our awareness that we are building a memory, and without processing and working memory. So let's look at some of the automatic processing. Some experiences go directly from long-term implicit memory, or go to long-term implicit memory. Procedural memory, such as knowing how to ride a bike and well-practiced knowledge such as word meanings. Conditioned associations, such as a smell that triggers thoughts of a favorite place. Information about space, such as being able to picture where things are after walking through a room. Information about time, such as retracing a sequence of events if you lost something. Information about frequency, such as thinking, I just noticed that this is the third texting driver I've passed today. So the first phase of encoding and processing is our sensory memory. The immediate, very brief recording of sensory information before it is processed into short-term or long-term memory. We very briefly capture a sensory memory, analogous to an echo or an image of all the sensations we take in. How brief? Sensory memory consists of about 3 to 4 second echo, or a 1/20th of a second for an image. Evidence of auditory sensory memory, called echoic memory, can occur after someone says, "What did I just say?" Even if you weren't paying attention, you can retrieve about the last 8 words from echoic memory. It's still sort of bumping around in there. And here's some evidence of visual sensory or iconic memory using George Sperling's experiment, or a version of it. George Sperling, 1934, exposed people to about a 1/20th of a second view of a grid of letters, followed by a tone, which told them which row of letters to pull from iconic memory and recall. Without the tone, people recalled about 50% of the letters. With the tone, recall for any of the rows was typically 100%. To simulate Sperling's experiment, notice the 3 rows of letters below. Based on the color of the letters, you will know that you must recall one of the following rows. Top, you can see the color for the top. Middle, you can see the color for the middle. Or bottom, you see the color for the bottom. So when the letters appear, they'll be of a certain color, and that will tell you which row you should be paying attention to. Let's try it. Okay, so it just happened. So you should have been able to recall the letters. Just say them out loud to yourself. There you go. So this sort of demonstrates what they went through doing the Sperling experiment. If we have some clue as to what to focus on, our memory, the image of our memory, our visual memory, is there long enough for us to pull it out. Now let's look at the capacity for short-term and working memory. If some information is selected from sensory memory to be sent to short-term memory, how much information can we hold there? George Miller proposed that we can hold 7 plus or minus 2 bits of information. For example, a string of 5 to 9 letters. More recent research suggests that the average person free from distraction can hold about 7 digits, 6 letters, or 5 words. Working memory depends on concentration. Despite this talent, it is generally a myth that we can handle 2 streams of similar information simultaneously. Here's a test. See how many of these letters and numbers you can recall after they disappear. Let's go ahead and start. So, can you recall those letters and numbers? Here they are. Dash V M 3C A Q 9 L and D. So, the duration of short-term memory. Lloyd Peterson and Margaret Peterson wanted to know the duration of short-term memory in an experiment in 1959. People were given triplets of consonants, for example, VMF. To prevent rehearsing, the subject had to do a distracting task. People were then tested on various times for recall. Results after 12 seconds. Most memory of the consonants had decayed and could not be retrieved. So the percentage of who recall the consonants, you can see 90%, down to 60% around 3 seconds, around 30% after 6 seconds, but after 12 seconds we see a major decline in your ability to recall that information. So now let's look at encoding, effortful processing strategies. If we have a short-term recall of only 7 letters, but can remember 5 words, doesn't that mean we could remember more than 7 letters if we could group them into words? This is an example of an effortful processing strategy, a way to encode information into memory to keep it from decaying and make it easier to retrieve. So, we call this effortful processing studying. So here are some examples: chunking or grouping, mnemonics, images, maps, and peg words, hierarchies and categories, rehearsal, especially distributed practice, deep processing, semantic processing, and making information personally meaningful. Can you remember this list? So, chunking. Why are credit card numbers broken into groups of 4 digits? 4 chunks are easier to encode or memorize and recall than 16 individual digits. Memorize the following. Chunking or organizing the data into manageable units will help. It even works better if we can assemble information into meaningful groups. The same list of letters: X, IDK, KFC, FBI, BA, NAACP, CVS, SUV, ROFL, NBA, Q. So obviously, our ability to recall information is going to be more significant if we do some grouping and also make it more meaningful to us than that more unmanageable list of letters. Is going to be much more manageable. So here are some strategies as well called mnemonics. Plain, cigar, do, shall, candy, vague, pizza, seam, fire, pencil. Which words might be easier to remember? Write down the words you can recall. We encode better with the help of images. Cigar, pizza, pencil. A mnemonic is a memory trick that connects information to existing memory, strengthens such as imagery or structure. A pegwork system refers to the technique of visually associating new words with an existing list that is already memorized along with numbers. For example, do can be pictured written on a door and door equal 4. Here are some other strategies using hierarchies and categories. We're more likely to recall a concept if we encode it in a hierarchy, a branching or nested set of categories and subcategories. Below is an example of a hierarchy using some of the concepts we've just seen. We have encoding and effortful processing. Underneath it goes to sensory memory, then capacity of short-term memory and working memory, and effortful processing strategies such as chunking, mnemonics, and hierarchies. Here's another way to look at the same information. So by having these visual images, the information is going to be possibly more accessible to you, so you can recall it. So rehearsal and distributed practice. Massed practice, cramming information all at once, is not very time effective. The spacing effect was first noted by Ebbinghaus. You will develop better recognition and recall, especially in the long run, if you use the same amount of study time spread out over many shorter lessons. This doesn't mean you have to study every day. This basically said that the longer the time between study sessions, the better the long-term retention and the fewer sessions you need. The best way to practice, consider the testing effect. If it was found that if your distributed practice includes testing, having to answer questions about the material, you will learn more and retain more than if you merely reread. So the idea here is that as you are studying, you should have built-in testing protocols so that you have a way to test yourself. This strengthens your ability to store and retrieve that information later. Then we have deep semantic processing. When encoding information, we're more likely to retain it if we deeply process even a simple word list by focusing on semantics, the meaning of the words. Shallow, unsuccessful processing refers to memorizing the appearance or the sound of the words. So here's the type of processing. Deep, semantically, the meaning of the word. Then we have a shallower form of processing, the sound of the word, the rhymes of the word. And the most shallow, the structure, the appearance of the words. Let me give an example of an experiment I used to do in my face-to-face classes. I would pass out a list to the entire class. The class did not know, however, that I had changed the instructions. It was the same list, but the instructions were different to half the class. One half of the class had instructions to count the number of vowels in the words, and they just write the number next to the word. The other half of the class were told to think of the word as being pleasant or unpleasant and write a P for pleasant or U for unpleasant. I then took up those list of words with their answers as to the number of vowels, or pleasant or unpleasant, did some other distracting type of lecturing task, and then later asked them to take out a piece of paper and write down as many words as they were able to recall. The students were able to recall more words if they were part of thinking of the word as pleasant or unpleasant, which is a deeper form of processing the information. Those who counted the vowels, they remembered very few words. Those who thought of the word as being pleasant or unpleasant, deeper processing, remembered significantly more of the words. Another way that we can do this is to do the following. Memorize the following words: bold, truck, temper, green, run, drama, glue, chips, knob, hard, vent, rope. Making information personally meaningful. We can memorize a set of instructions more easily if we figure out what they mean rather than seeing them as a set of words. Memorizing meaningful material takes 1/10 the effort of memorizing nonsense syllables. Actors memorize lines, and students memorize poems more easily by deciding on the feelings and meanings behind the words, so one line flows naturally to the next. And then we have the self-reference effect. Relating material to ourselves aids in coding and retention. Now try again, but this time consider how each word relates to you. Bold, truck, temper, green, run, drama, glue, chips, knob, hard, vent, rope. So hopefully you'd be able to recall more of the words if it had some sort of self-reference involved in it, that you can see how they are meaningful to you personally.